This is the oldest light we can see in the universe, and that patch right there is too cold. Not freezing cold. The differences on this map are tiny, millionths of a degree. But this patch is unusually cold and unusually large in a way that makes scientists stop and argue. It's called the cold spot. And here's what makes it different from most space mysteries. This isn't a photo of a galaxy or a black hole. This is a map of the universe's afterglow, the faint background light left over from the early universe. Scientists call it the cosmic microwave background, or CMB. Think of it as the universe's baby picture. On that baby picture, you expect mostly random speckles, tiny hot and cold variations scattered everywhere. But the cold spot isn't just a speckle, it's a whole region that stands out like someone spilled dark ink on a scan that should look mostly uniform. So the mystery becomes simple and dangerous. Is it just a fluke? Is something massive out there changing the light as it travels to us? Or is it an imprint from the early universe that we still don't understand? And I'm not going to drown you in physics. You only need one idea to follow this case. If the CMB is the universe's first fingerprint, then a patch that looks wrong could be a clue, or a trick of statistics. Tonight, we treat it like a case file with three main suspects. A statistical fluke. The universe is huge, so something weird might appear somewhere. A giant cosmic void, an enormous empty region that could affect the light passing through. Something more exotic. A rare imprint from the early universe itself. And by the end, you'll know what the evidence supports, what doesn't quite fit, and why one too cold patch is still one of the strangest problems in modern cosmology. So where did this cold spot come from? Scientists didn't stumble onto it by accident with a backyard telescope. It showed up when they did something much bigger. They mapped the CMB across the entire sky using satellite data, turning that faint afterglow into a detailed temperature map. And when those first high-quality maps came in, one region stood out. Not because it was dramatic like an explosion, but because it was quietly wrong. Here's a useful way to picture the scale. If you hold your fist out at arm's length, that's about the size of this patch on the sky. Big enough that you can't shrug it off as a tiny pixel glitch. And the reason this became a real scientific argument is that it didn't vanish with better data. As mapping improved, the cold spot kept showing up. That doesn't prove it's something exotic, but it does move the mystery from maybe noise to, okay, why is it there at all? Because in a map that's supposed to look mostly like random speckles, a big region that stands out creates a problem. And the next question is the one that decides everything. Is the cold spot weird because of what happened in the early universe? Or weird because something huge is sitting between us and that ancient light? Here's why the cold spot became a real argument. On a CMB map, tiny hot and cold speckles are normal. But this isn't a single speckle. It's a whole patch that looks colder than the area around it, and it's large enough that you don't dismiss it as a tiny glitch. Now, there's a trap in anomalies like this. When you scan the entire sky hunting for something strange, you'll probably find something strange. It's like flipping a coin 1,000 times. Somewhere you'll see an unusually long streak, even if nothing supernatural is happening. That's why the first suspect is the simplest. Suspect number one, it's a statistical fluke. A rare pattern that just happened to show up. But if it's only chance, one question decides the case. Why does this patch keep looking wrong, even as the data gets sharper? So what does a statistical fluke mean in this case? It means the cold spot might be a rare pattern in a giant random map, nothing more. And scientists can test that idea pretty cleanly. They run simulations. They generate thousands of CMB-like maps that follow the same basic rules and ask one brutal question. How often does a patch like this show up by chance? But here's the trap that trips everyone. If you point to one exact spot and say, "Is this weird?" That's one test. But if you scan the whole sky hunting for anything strange, you're basically saying, "Show me the weirdest thing anywhere." And when you ask anywhere, you're much more likely to find a monster, even in random data. That's why some researchers say it's unusual, but not impossible. Then the counterpunch. The cold spot isn't a tiny glitch. It's a large, coherent patch, and it keeps looking odd even as the maps improve. So, suspect number 1 stays on the board, but it doesn't close the case. Which brings us to the explanation many people want to be true, because it sounds so physical and so simple. What if the cold spot is caused by something huge in space, sitting in front of that ancient light? So if the cold spot isn't just luck, what could physically cause it? This is where suspect number 2 enters, the most popular explanation that doesn't require new physics: a giant cosmic void. A void is a region of space with far fewer galaxies and far less matter than average. Not empty like nothing exists, but empty compared to everything around it, like a thin patch inside a dense cosmic web. And the scale here matters. We're talking about a region so large on the sky that, if it's real, it would be one of the biggest missing matter neighborhoods in that direction. Here's the simple idea. The CMB light has been traveling for a ridiculously long time to reach us. If that ancient light passes through a huge, underdense region, a massive, thin spot, it can end up arriving slightly altered. So the void theory says this: the cold spot might not be a scar from the early universe at all. It might be the CMB shining through a giant, emptier region closer to us. Sounds neat, sounds testable, but there's a catch, and it decides everything. If a void is causing the cold spot, then when we look in that direction, we should find a real, enormous shortage of galaxies. And when scientists tried to check that, the story got complicated. So what happened when scientists actually checked the giant void idea? They ran galaxy surveys, basically a cosmic headcount, and asked, is this direction of sky missing galaxies the way a true void should be? Some studies did find something that sounded promising, a void-like region in roughly that direction. That's why this suspect became so popular. It's a normal universe explanation, no wild new physics needed. But here's the problem. To create a cold spot this noticeable, the void would have to be huge and structured in just the right way, not just a slightly emptier neighborhood. And that's where scientists split. Some argue the evidence isn't strong enough, or the void isn't big enough, or it doesn't match the map cleanly. So suspect number 2 stays alive, but it doesn't close the case. Which forces the uncomfortable question. If it's not just chance and not fully explained by a void, what else could leave a mark like this on the universe's oldest light? So if it's not just a fluke, and the void idea can't fully carry the weight, we're left with suspect number 3. This is where scientists slow down, because it's the most tempting to exaggerate. Something unusual in the early universe left an imprint, and the cold spot is that imprint. Here's a simple way to picture it. The CMB is like the universe's first surface. Most of it is random speckles, but if something rare happened very early on, it could leave a larger scar, a patch that looks out of place. Researchers have explored ideas like a rare early universe feature that created a colder region, an unusual structure that affected the CMB in one direction, or other speculative early universe events that could leave a localized mark. But here's the rule that keeps this honest. Big explanations must leave extra fingerprints. If the cold spot came from something exotic, it shouldn't be one cold patch and nothing else. You'd expect side effects, patterns around it, related shapes nearby, or other subtle signatures that appear in the data in the same direction. And that's why suspect number 3 is still open. It isn't thrown out, but it also isn't strong enough to force a unanimous verdict. So now the cold spot sits in the most frustrating place a mystery can live. Either it's a rare coincidence that looks meaningful, or it's a real clue from the early universe that we haven't decoded yet. And the next question is the one viewers always ask, and scientists argue over. So, which explanation is winning right now? And what would it take to finally close the case? So, where does the debate stand right now? Most scientists agree on one thing. The cold spot is real on the map. It's not a rumor, it's not a clickbait story, it's a genuine feature in the CMB data. The fight is about why that one patch looks so too cold. If you line up the suspects, here's the honest scoreboard. A statistical fluke is possible, because in a sky this large, rare extremes can show up somewhere. A giant void is plausible, because it's a physical explanation we can try to measure with galaxy surveys. An exotic early universe imprint is possible, but it needs stronger extra fingerprints before anyone can call it the answer. So what's the most reasonable view? Many researchers lean toward a blended explanation. It could be a rare cold fluctuation, basically a bad roll of the cosmic dice, made more noticeable because the universe in that direction might be a bit thinner than average. Imagine a small dent, sitting on top of a shallow dip. Separately, each is explainable. Together, they look like a problem. But the reason the cold spot still matters is that it's not done testing us. If future galaxy surveys show there's no void big enough to help explain it, and improved statistics still say this shouldn't stand out this much, then that too cold patch stops being a curiosity and starts looking like a clue from the early universe we haven't learned to read. And that takes us to the final question. After all these suspects, what do we actually conclude? And why does this one patch keep surviving every attempt to close the case? So what is the cold spot? The most honest answer is the one people hate hearing. We don't have one explanation that everyone agrees on. A fluke could explain it, but it feels like a weak ending. A giant void could help explain it, but it may not be big enough. And exotic early universe ideas are possible, but they still lack the extra fingerprints that would seal the case. So the cold spot remains what it's been for years, a visible patch in the universe's oldest light that refuses to blend in with the random speckles it's supposed to be. One map, one region, and one stubborn label that keeps coming back: too cold. And that's why it's a perfect cosmic vault mystery, because it isn't a rumor. It isn't a myth. It's a real feature in real data, with real scientists still debating the cause. If you want the next case, we're staying with the same rule: one anomaly, one investigation, one verdict. Because the next mystery is even more unsettling. A star that keeps dimming in patterns that don't behave like normal planets, and the deeper you look, the stranger it gets.